no! Where's my face? Ah, here I unprepared stream. Hello everyone. Let me zoom in. So, here we go. Yeah. Who is online today? Okay, so we have Peter, we have Christian, Aaron, Quindor, Chris, M40K, Lars. Hello everyone. I'm unprepared. I'm looking horrible today. but we are not for the looks here, aren't we? Fade. Look behind me. I started to clean up my my lab, and actually today, it's like we get a huge echo from back there. I think this is reflecting very hardly. Oh no, that's too direct light. Ah. Okay. How unusual. Yeah, so I don't even have a fondue for today. I ran out of fondues and I didn't order since the last one that I ordered was, the packaging was quite wasteful. And if I go to a Rewe, which is a shop that's not close by, I can get them the fondues easily without like the whole procedure. Oh, it's like the echo is terrible. I can hear myself from the back because I removed everything. I zoomed out. I removed everything from the back wall, including my YouTube button and everything. And we can basically move the LED wall to the back. So the camera will be pointing always at me and the LED wall in the back, so we can do a project with the LED wall if you want to. I vote for pink LED stuff. Let's begin. Okay. So we can't do the fondue stirrer today because I don't have a fondue set up. Let me check, grab the list of the projects that we pitched before. Please pitch more projects. I didn't announce it on the main channel. It's like today is the core crew. Shall we announce the stream? I will share it on at least on my main channel. Community. Let me announce it there. Okay. Live now. You. And on Twitter. That's easy, so I don't have to like calculate anything or okay. And there you go. This is done. Fix fail robot. Yes, we can do like. I also want to. So let me get the sheets, or was it how? What's the forms? Forms Google. Maker challenge. No, how do I change it? Okay. And ESP 8266 from TTL and discrete components. Oh, Duncan. I don't think that I have the proper components available here. With a mirrored PCB. Hello, Info Mario Royce. You can use YouTube, Paul. But yes, I can. I will. But we need to check on the. Let me do desktop plus face. Pew! And zoom in what we had before, what we pitched before. Okay, Fondue Stereo Maker. I think the YouTube poll gives only like 4 options max. Yeah. We have only 4 options. So we can pick from those. I would add a proper text-to-speech. So I don't know what you think, but I liked the text-to-speech stuff, but it was like broken. Fix fail thing. Okay, yeah. First option will be fix fail thing. How about we fix that and add text-to-speech, a proper text-to-speech. How about that? Hey, Sniff. So I will add to the list. Where is it? Okay, chat controlled alarm plus text-to-speech. One that works every time. We could use like an code, something, floppy drive on an ESP32. Do I have a floppy drive? I think I only have I might have a C64 floppy drive. Hey, Anna. Add text-to-speech, yes. We had this text-to-speech before with Node-RED, but it was like failing all the time. So LED ceiling or floor. Okay, Anna, this is like, you mentioned it now, but that's like something. Can I add another? How do I change it? I can't edit it. How do I edit it? Add an option. Oh, okay, here. LED floor. Let's say ceiling, because I got components today. I have like, look at this. Aluminium profiles, 2 meters long, six pieces. And I actually plan to mount them to the ceiling, and everything that's always standing in my way here, like the tripods and so on, everything I will mount on the ceiling, and I will probably use parts of LED wall 3, the paneled one, to attach it to the ceiling and have proper lighting that is controllable. C64 floppy does not count. It has too powerful. Yes, too powerful. You should render the TTS to MP3, then play it. Was it expensive? This is like the 40mm profiles, and I paid for 6 times 2 meters. I paid like $75. They have also like for like 140 or something, 130 euros. This was from eBay. The double width. I thought maybe that would be more appropriate for the ceiling, but I just started with these ones because it's below $100 and I can start to like add stuff, like especially the lighting, because it's standing on those tripod pods that are always in my way and I hate it. I want to fix that. I actually wrote a very, very bad 6502 emulator in Python a few months ago. It's terrible. Terrible. It's the theme of our stream. No fondue today, Lars. I'm sorry. I'm out of fondue. I didn't have time to buy any. And I'm quite full. I did bolognese yesterday and we had still some left, and I ate the remains today. Real-time MIDI to G-code adapter, I meant. Okay. What? Frank? Real-time MIDI to G-code adapter. That is interesting. Isn't that somewhere like done before? Let's go with color. What's CRI? Color reproduction index of 10, 10%. Not real time. This, not real time. Okay. Can we do like, because I don't have my theme as MIDI, can we do it like in, but that's only coding, that's no. But let's do music, MIDI to G-code. To G-code, that's one pitch, okay. Oops, that's MIDI to G-code, or music to G-code, okay. Let's do something with VGA then. What happened to the ping pong? Oh yeah, ping pong shooter. Ping pong Nerf gun. Musical flute controlled by, okay. Hello, Jay. It will have to be a ping. VGA interface for the LED wall. Yeah, that's what I'm thinking about. How do we do this? Can we do like this ADC so quick? Okay, so we have ping pong Nerf gun, and we had what Aaron says, flute. Flute with chat controlled flute. Oh, terrible. That will be like, okay, I think Okay. Let's test. Okay, what do we build today? And now ask my community. Here we go. I will just stop the poll once the thing wins that I want to win. Look at these things here. I prepared them to be mounted to the ceiling. So I have this cage for the GH5 because I want the camera to be not upside down. If I mount it like that, I want it like this, and I can use basically either this thing or whatever to mount it somehow to the ceiling. But I don't know what I will use in between, because like only a piece of the extrusion will be like not very stable. Okay, what do we have? Can I vote too? I don't know if I can vote. I can't vote. That's Nerf gun wins. No, it's a close one. It's a close one. Do we set like a deadline for the vote? We can chat a little bit. We should set a deadline. I won't look in what it is. How do I vote for it? I can vote. Ah, Nerf gun. The theme is for the Nerf gun. How do I even... we can't print stuff so quickly, but actually we could. There's more votes than viewers again. How can there be more votes than viewers? We have, I check how many viewers we have. The extra effort that people are going through to log in with different accounts might be worthwhile. So we have 26 viewers. So actually it's not far off right now. Yeah. People cheating. Vote is over. TTS Johnny. I see 35 viewers. And we have 41 votes. Me, myself, and I have voted. What Johnny said. Oh, TTS. Yeah, I would love to do TTS. So let's get over with this Nerf gun, ping pong Nerf gun, and then we can do TTS on top. Yeah, I have to improvise that. I have no clue. Maybe we can... Stichwahl. Oh. So do we do another vote between the two? like presidential election here. Okay, let's do... I like the flute as well. Pure democracy. Now we are in Germany here. The voter, more votes, yeah, but the voters win. It's quite close though. Not needed, I say TTS1. But how do we do we really want to use like the CO2 for that? Keep voting till I win. No, I think we need to do this this gun thing. Okay, let me get the parts while you still try to turn the votes. Should have suggested a MIDI flute. Yeah. Ah. Okay, if we add, it's still not winning. MIDI code and flute isn't added together is only like 31%. It's still not winning. You need to vote to bottom screen. How do I vote there? I can't vote. Not in this view that I'm here. Okay. Okay, people, let's try. Let me get the parts. I hope I have everything here. I have no clue how to build it though. Do we use this CO2 thing? Because it appears to me that okay, we have CO2 here. People are cheating. Hey Brian, you missed the vote. MIDI flute recorder was already... Okay, so CO2, how do we connect it? I need some piping. Okay, let me set up a camera. We can work on the table. The problem is to get the things, the prints done, because we don't have like... Okay, where is the camera? Next time I just decide. So we do this, where's here? GH5. You can see what's happening right now. But I'm basically setting this up here. Okay. Oops. Okay. Let me check if we can get some other view. Okay. maybe a little bit more light here, or I switch to a higher ISO. Okay, so we don't need that. Yeah, it's complicated without the fail thingy. Okay. I need some piping, so let me grab tools. Okay. This tube could work. It's like a silicone tube. Can we? Yeah, I think that would work. Yeah, that can work. Otherwise, I might be able to disconnect this part here. Is it possible? No. Ah. Yeah, I will wrap it later. Don't have a thicker tube than that. What is that? It's a PSU. Round ball nerf gun 2 motors with RC car wheels to speed the ball up. Yeah, that could be better. Michael, that could be better. So actually, that's okay. CO2 is too wasteful maybe. If we can make it with RC car wheels that we don't have, but something similar, we can build something similar. I need some ping pong balls. Where do I have the motors? Okay, I think this pipe is a little bit too much. Let's rather print it. We have some motors. This is like a speed controller and a motor. Outrunner, we can basically use that one, or like this. we can use this one. It's like, I think this is like 24 volts. I think this one wasn't broken, this speed controller. Yeah, that's burned. But that one should work. So here's a... Oh yeah, there is another one. That's the inner runner. That one could work as well. But I just, this one is proven to work. So let's keep that. That's an option. How do we do this? It's like, okay, servos. I need a servo to control pitch and stuff. Here. A few servos. I think 2 of these are okay. Control these things. I stand up. I use a big one too. Piece of bicycle tube. Yeah, that's what I thought. Or like something similar. Let me check. We can. Oh, that might be interesting. Toilet paper rolls. It fits, okay. Then let's remove that. Smaller. I don't have, unfortunately, I don't have a printer with like a really, oh, that's not even tight. Yeah. How is it? Oh, yeah, cool. That's easy. Okay. So first of all, we need something to aim. Like this contraption, because we don't want to print a tube like that. Maybe we can, we shouldn't. I don't know if how fast we can. I should bring in like the 2 printers, or and they are loud. Is it even? Oh no, it's out of focus all the time. I'm sorry. Fail. That was the first fail of today. Okay. So one servo, like a small one, let's say one of the 9 grams, will reload it like that. We'll move the ball, and we will have like basically constant rotation here. Like this will be always on, like full speed rotating with, yeah, we just print something and do some rubber around it, and it will shoot out. Then we need some aiming Let's construct it. I don't, a PVC pipe, I can't find one. Let me check if I can find a PVC pipe. Ah. Okay. Yeah, it's like we could work with that, but how do we reload it? Okay, we cut in something like that, and we need it's a little bit too wide, I think, the PVC pipe. We can check if we can print it. Okay, let's try. Oh, another thing. I had a battery pack here. It's my battery pack. What do we connect here? This is okay. That's 14 volts. It's too high. Need a smaller one. Volts. Nope. I'm looking for a battery pack. This will be like, oh wait, I think this one provides 5 volts here, does it? PWM, yes. Okay, I think this provides 5 volts. Let's try this outrunner here. What's minus? What's plus? This is signal. Is it armed? Okay. Well, I think that's the wrong thing. Is it dead? Oh shit! No! Oh no! They touched. That's terrible. I hope the ESC still working. Oh no! It was touching. the contacts. Oh no! It was like sparking all the time. Oh no! That was terrible. And it's twisted. I probably destroyed an ESC right now. Let's check what's happened. Ah, terrible. Drill it to the table. Microseconds since last accident. Yeah, we had almost the battery pack exploding here. Yeah, I hope the driver's still working. Okay, let me add some insulation here. Let's try again. Uh-oh. Ah, okay. Okay, it lives. You didn't see anything, but okay. Okay, this part is working. Oh, okay. Yeah, okay. We got this part working. It's a quite durable ESC, I must admit. A Vesk would die immediately. It's like 60 amps brushless ESC. Super cheap one, no name from AliExpress. Okay. So let's set up our checklist. Since we need a checklist now. Text, build phase. Okay. Ooh, that's a too huge build phase. That was our last one. Okay, so what is let's call it, because I don't like guns. I'm a pacifist. Let's call it ping pong indicator. So because you can aim, I will call it indicator, because you can aim at stuff and indicate it. Okay, so this was old stuff that we fixed or not. Where is the checkbox? Ping pong pong. Launcher. Yeah, like a rocket. Yeah, that's more. Let's call it ping pong launcher. Ping pong launcher. So first step is we need to see a CAD drawing of the parts that need to be printed, like CAD orders, print parts. Okay, print part, print X, Y. No. Let's do it like print the X part and then print the Y part. Launcher wheel, tube, okay, so extra is pink LED. Ping pong with a pink LED inside. Okay, yeah, pink LED is, we need to, okay, so card models, X, Y, launcher wheel, tube. Then we need chat control, and we need to really, oops, control, chat control. Is it chat controlled? Ludicrous, ludicrous names for the parts. Yeah, please Sniff, come up with the names. You could keep the cat on the list. Oh, cat? What cat? Fire on fail. Okay. Okay. Chat control. And then what do we need? Okay, we can add stuff as we do it. Let me steal the icons. I need somehow to put the icons in some kind of list. We have here like, let me get that. There's no checkbox, no unchecked checkbox. I lose it all the time. Okay, let me grab that. Yes, Sniff, that's what we need. Airflow to fire it. I don't know. I will just do it with servo control. Oh, we need to control the servos. Okay, let me checkbox UTF-8. Okay. Okay, this is the unchecked checkbox. Chat control and PWM control, okay. Because we need to add this PWM module. Oops. It's quite a long list. Oh, let me grab that. Accident. Okay, we had an accident already with the with the shorts. I don't know how on camera this was or not. Okay, let's do it like that. And now we need CAD models because we have only a limited amount of print time available. Motor with propeller in bottom of pipe with hopper for the balls. Yeah, I will just use, let me do a design for you. let me do the design part for you here. Come on, here. Here I am. No, that's not me. Here we go. Fake blood outside of the boards. Okay, so let's draw something with the mouse. Okay, so this is like the cross section of the launcher part. So we got like, this is the tube where we have the balls coming in, and this is the tube part that launches it. Here is the wheel, like very fast. Fast. It might even have like a bump like that to initiate it. And then we have basically the small servo, because we have servo controls anyways, like that, that will basically push the ball on the launcher wheel. That should be enough. Dot-dirty drawings. This is a servo. Okay, and then we need rotten eggs. Okay, and this needs to be mounted. I want this as an NFT. Okay. Yeah, sure. And then we need, okay, so this will be mounted like on an axle here. That's like that. This is also servo controlled, but we can show this from here. And this is also like rotating. So this is also rotating. And this is also rotating. And that should be all. And we need to print this part. The tube here. The tube takes the longest. Okay. Do we do it? Do we do it in Blender or in FreeCAD? What do you prefer? We need to do it quick. I'm not sure. Last time it took me a day to do the designing. Too big. I need to add this to this screen as well. Oh, come on. Why is this control so cumbersome? Okay. Fusion, no Fusion here, sorry. Fusion isn't free. I refuse to do it. I don't have a Fusion. I wasn't able to obtain a Fusion license, a free Fusion license. And really, either it's FreeCAD or I'm showing everything on my screen, doxing everything. What's the new? Ping pong launcher. Okay. Yeah, it's free for hobbyists. I think I applied and it somehow failed or whatever. I really don't want to have something where the server, I'm dependent on the server, and when it's down, I can't work with it. And Onshape, what is Onshape? Okay, let's start FreeCAD. That's the problem. Luni is a professional. Yes, I am. Okay, so either we start with FreeCAD or I do it in Blender, and it will be so quick that it will be jaw-dropping for you. Okay, it's dodgy anyway, so let's do Blender. Fusion is local, yeah, unless you want to log in your account. I don't know. The last time I used Fusion, it was so... Let's stick with that. Use HTML and CSS. Let's go. Okay. Okay. Let's do it. Let's not. Okay. Let's design the biggest part first, and that's the tube. Do it in Blender. Yes, I will. Okay. Delete the cube. We need to create a cylinder, and the diameter of the cylinder or the radius is 40. No, 20 millimeters. 20 millimeters. Depth is... How long is the tube? Let me get a caliper. Okay, so I will measure what we need right now. So either we make it even smaller. This is the outer diameter, because the bolts that I got are only 37 millimeters, I think, yes. Yeah. The ones I got are... got to be foot long. we only using here metric. Sorry, not sorry. Okay, so this is like 40. Yeah, it's not quick. 30 millimeters, that's too huge. I will make it 15 is already plenty. 15, and this will print forever. So it's like, if we do it like 150, this will already print forever. Wall thickness, let's duplicate. Duplicate and let's use only 2 walls. It will be very like easy to break, maybe. So how do we how thick will be this one. Uh, 0.8, then it's 38 point 0.8164. Okay, that's the inner tube. You can't see anything, I know. I'm just typing numbers. Okay, so, and this is, should I make the window smaller so you can see everything? Let me make it a little bit smaller so you'll be able to see stuff, and move this thing down. So I will add a modifier, boolean, then difference, I use carve, and I'll pick the other one. And this is our tube already. Oops. Okay, and this one is, okay. Then we need the loader tube, cheese fondue printer. I need to move to this screen here. Okay, we need to be able to tilt it, and we need the second tube here. Let's duplicate it to as a loader. The loader doesn't need to be a tube though. It can be, we can cut out stuff to make it print quicker, but I'm not sure if this will be possible. Okay, let's rotate it by, no, that's not the right one. Is this the right one? Yes, okay. Yeah, that's not the right one. I need the other tube. Okay, this one here. Wait, what? Cavity? Oh, yeah. Basically, like, it doesn't need to be as high. How many balls do we want to put there in? Let's do it only 12. Oops. 12. And let's put it -60. And let's do it like that. 4, 5. Okay. Let's take the cavity. Oops. Rotate it by 90. Should have taken it. Oops. It's the same. Basically, wait. Now let's stop this and use the parent function, and this is the parent. So we don't need to rotate anything. It's basically like that. and the other cavity is also parented by this, by this one, cylinder. For the loader, just angled pipe behind it and gravity work for you. Yeah, this will be basically it. It's like, you need to imagine that, how do I rotate it? Oops. Ah, what did I do? What did I do? Oh wait, this one here. Apply scale. And this one apply scale. Okay, this is right. Then we need to add another boolean and another boolean. So this goes up, and this is union, and this is this cylinder, and this is difference, and this is that one here. And we need to carve everything. Didn't work. No, it's broken. Yeah, that's that's an issue. Okay, was this the last B mesh? Yeah, that's already a broken mesh. Let me take the cavity. And make it slightly longer. Proper cut software. Not that quickly. I'm sorry I can't. That's like SketchUp 3D. This won't load. No, this not needs to be up till here, like that. Why did this not work? Okay, let's do it like that. Remove this cavity and cut it first. I was watching Wintergattern. Come on. And it took him ages to do anything, so please. Come on. Can I pick it already? Yeah, I just type it. Here we go. Okay. Okay, that's the first. That's not clipping in. No, we need to move it over here. Crap. Okay. We need to cut it last. The method doesn't work, okay. This didn't work, my whole Blender experience in 10 years. Yeah, Peter, the problem is that I need the thing that prints the longest. I need to finish it first, and then from there on we can add all the other stuff. So basically we need to do this right now, otherwise we won't be finished in time. This already prints like hours, so we can take our time after that, but currently it's unfortunately we need to do this first. Like that. So let's remove it. Some strange. Yeah. Okay, I don't care. It looks already good. Okay, now we need something to. Should we like hot glue everything at the end, or should we add stuff right now already? So I will add like an axle. You print what I see. It won't help with anything. What? Use the PVC. The PVC has too wide diameter. We wouldn't be able to catch the ball really. This is like, please trust me. Please trust me in this case. And then you have the I told you moment later, okay? I give you the I told you so moment later. So this will be the cutout for the ball launcher thingy here. Let's basically make it like proper numbers here, 19, 28, like that. Now it needs to be more like here. It will already catch it. Okay, a little bit more up. I'm afraid that it will like instantly be caught there. Okay, let's do it like that. Let's hope it works. Okay. Add another Boolean difference. And we basically hide that one. Okay. So this is where the mechanism, where we have the spinning wheel. This will be the spinning wheel. Now we need something to mount the spinning device to. Oh, shoot. That's like, oh yeah, we have something here. They're like mini screws. No, this is not working like that. This plate is like very far away. Oh, we don't use the axle at all. We can just use the outrunner. Yeah, we basically... 2 wheels to avoid getting one. Oh yeah, or we do a wheel that is like with a V-groove or something. 2mm aluminum extrusion. Okay, so we can even use the outrunner for that. What's the diameter? Okay, this is like 25, 35 millimeters. Yeah, that's perfect. That's basically the cutout. If we put like a bicycle tube on top of that, it will be good enough. We just need to mount it properly. That will be like, we need a plate, 30 millimeters. We can basically add a box there. Let me add a cube. We will drill the holes. I don't measure right now because then we can basically drill the holes to mount the outrunner there. We can make it a little bit thicker. Oops. Okay. Something like that. How many millimeters this is? I think this is okay. I think we need it like here. This will be the outrunner. This is 1 centimeter. Let me check. We just need a little bit playroom here. 34. This must be 12 millimeters, I think, at least, or 4 layers. 4 layers will be 1.6. Let's leave it 2 millimeters. 2 millimeter thickness. And this is 35, 40. So we need 1 centimeter is around here. Another centimeter. This is the center. So we need to pull this out like maybe that. This is what we need here. And do it like that. So we have a little bit room to mount this thing. I don't know how we want to print that. Maybe flat or something like that. This is already not possible because we got a challenge for you. You can design this thing in Fusion while I'm doing it here in Blender. And if you have finished before I am, you can send it to me and I will use yours. Yeah, I have enough space for the bicycle tube thickness or other stuff that I could use for that. We have plenty of room here. So this will be outrunner. Maybe we can even use the plate on the other side to fix the outrunner because we have the axle here. We'll just use it on both sides. So let's clone it and put it to the other side as well, like that. Oh, we should basically mirror it. I think mirror. Mirror objects. Okay. Oops. Like that. Okay, mirror. That's easy. Now let's use this. Oh, there's already something broken. Oh, I used the wrong one. I destroyed the cavity. No, where's my cavity? Like that? No. I'm not sure how this will print. There's basically no flat surface to put it on the 3D printer. We can print it like that, probably, with a little bit support down here. This will be terrible. It's the worst project ever. Okay, how do we put it through here? That's like, that's not thought through. Let me check if I can remove the axle here. No, can you? No, there's no way to remove this. No, that's the axle. Okay, I think this won't work here. The mirror won't work. Let's leave it like this for now. Let's leave it like this. My printer can't print that. Yeah, I will print it like that. And okay, now we need mounting for the servo and the hole for the servo, and no, this is not the view that I want. This is the view that I want, and I want this view. Oh yeah, we need to merge that. So let's collapse that here and add a Boolean union cube. Okay, now let's add another cube. I have no printer. Okay. So basically, how do we need a pivot here. We need a pivot, so I will add another box like that. Oops. Something like that. I'm not scared of breaking it off, really. We can support it with a proper amount of glue, hot glue. Hey, hobbyist. I have no clue what to do, what else to do. We can... Okay, you know what we can do? I will just duplicate this and do a short mount. Oops. Do we have like this? Where is it? Okay, second cube. Do something like that. Oops. And then, oh, yeah. And then cut a sideways groove in here, so the axle would be held in place. But I don't think this is like a super great idea. Let's leave it like that. Okay, maybe move it a little bit here. This is terrible. I love it already. What's the project? The project is, we can do, wait, I have ball bearings. But I really don't know where to put it. So we can put on the other side, we can use a ball bearing. Oh, that's the wrong size ball bearing, sorry. Shoot. No, this is the wrong size. Unfortunately, I don't think that I have this one. Okay, but we can just leave it like that. Mayhem. Okay. Okay, let's add it to this here. Did that work? No. Oh, wait. Huh? Where did I add that? Union. Yeah, whatever. Basically, we can hide everything except for this cylinder. And the last cube, where is it? Where's my last cube? This is the last cube. Yeah, this is the last thing that we started to do. Bitluni style, yeah. Yeah, we we will be watching the print speed. Oh man, that will be terrible. I tell you now, they will say it's like 20 hours of print. I can tell you that. Oh, come on. I'm not concentrated. Okay. Something like that. I'm not sure. Okay, let's center it, or transform origin to center of mass, and then let's do it like that. Oops. Here, this will be the pivot. Then we can, maybe we can use as a mounting plate, maybe we can use like a very basic construction. Okay, not sure if this is, how thick is this? 12 millimeters. Let's do it 20 millimeters strong. We need a sturdy edge there, otherwise it will break, because it's like attached to a hollow tube with a basic shoot. Okay. $11, and this will be also 11. Okay. Okay, like that, and now we need a mounting hole and a plate for the servo. Yeah, but let's do it my style right now. We can watch videos right now, or we can basically finish it, because I think we need only like 5 more minutes and we are done. Really, it's like super simple. We are already almost there. We are almost there. The one thing that we are missing here, oh, the mounting of the servo will be interesting. Famous words, yeah, it is. Watch with. The problem is I want it flat on the build plate like that. I will print it like that. And the problem now is that I also want to mount a servo here, the small servo that pushes the ball, but I don't want to attach any more parts here. We will fix it in post. Okay? 4 millimeters hole here, or 3 millimeters. Let's do a tube. Or do we do like 3? 3 might be enough. I have quite plenty of 3 millimeter. Let's do it like that. It's good enough. Good enough for that. And now let's do a mounting plate for, oh yeah, a small thing. We are almost done. We are almost done. The only thing that we can do now is to optimize the print duration. So this will be the cutouts for the servo horn. Something like that. Oops. Oops. How many millimeters? Let's give it a centimeter there. Like that. So we have plenty of workspace, workroom. I think this could be even higher, 30, and move it up there. Then I will duplicate it. Like that. And this will be the mounting plate. And I think we do only, we don't need much. -1. One layer will be 0.3 millimeters, so we need 3 layers there. That will be 0.9. Okay, this is the thickness of this plate. This will be the mounting plate for the servo. Which way around will be the servo here? The servo will be mounted like that to the tube. I think, no, this is better. Something like that, okay. I lost it already. Where is it? Here. And then we need rather here. Oops. And do it like 20 millimeters wide. We can basically screw something in this plate. Oh, we can't. They are the ping pong balls. Ooh. Okay, let's make it wider, like 30. Oops, 30. It's a little bit big. How high is it? 35. This is basically a mounting plate, 35. That's already plenty. Okay, 35. This will be on one side only. And since we mounted like that, need it here. Like that. Okay, let's leave it. Okay. Brain fuel. Did I miss something? Just make a little bolognese, yeah. Okay, one more thing. We need somehow to rotate this whole thing. Like when we want to tilt it, do we have something to attach to it? I think we just need one small thing. I will clone that one here. And add this. As an attachment point for like the servo to pull on. I mean the tilt servo. So let's put it like here. And I'll put it on this side. This is a terrible model, but it should work. Okay, so let's compile it now. Okay. We want to union that with, let me pick that from. Okay, then we need here. And we need to move it up. Oops. Can I move it? Like, no. Okay. Heh. Sometimes carve works better, sometimes different stuff works better. Okay. Now we need another Boolean and we need a difference of that thing. And we need also this one here. Okay. Boolean union this thing here. Yeah, and we need to move it up. Up the tree. Oh, broken, not broken. I think the mesh is already broken. Let me check that. Okay, I'll basically hide everything. Yeah. This is broken and I need this one now. Which one is it? Which one is that? Okay, this one here. I need this one also to subtract. We'll fix the errors soon. And we disable the cylinder. Okay, so this is our axle. Now we got this tube here. This is our print bed. Now we need to fix that. I think the error is more up there. The horror cut tool. Okay, let me deactivate one by one. Yeah, that's unfortunate that sometimes this is the one, this is carve. This already fails. This is carve. What does bmesh do? Let me check. Which one is that? Okay. That's this cavity. But this cavity already is broken. Let me... This is the union. This is the cavity. Okay, cavity, I will make it a little bit longer because it's exactly the same height. But we can make it slightly, can we even show that? So that's the problem. Like that. Okay, height cavity. Now we have plenty of different problems here. This is... Okay. Second cavity. Still working. And now we have that one here. So this needs to go up. And that's working. Okay, and this one needs to go up as well. Okay, and the rest is history. Okay. This is basically madness. I'm not sure about this thing here. This part here. Maybe we should add this slice here. But everything is already in place, so why not? I might want to remove that one here, this part. I'm not sure if this is even like feasible to use that. Yeah. Let's just disable that. Huh? Okay. Now we can simplify the print, speed up the print. Okay, I just store it right now. Let me store that. Where do I store stuff like that? Video, no. What's this ping pong launcher? Okay. Launcher. Save as Blender file. Okay, now let's export it as STL. Predict 8 hours print time. Okay, if that doesn't work, you picked the project. Please don't complain. Ultimaker Cura. So annoying. Cura tries to start. Oh, come on. I picked a pre-existing project. Yeah. Unfortunately, you didn't fake enough votes for the other one. Text to speech would be nice. So let's drop in. Where's my... Huh? There. Model errors. Okay, yeah, don't show me the... Let's see what the errors actually are. It basically it doesn't look bad. Oh shit, the support. I don't want this support there. Okay, let's slice it. Yes, we can try this. 6 hours. Okay. Look at this. Now let's optimize. Let's optimize it a little bit. So speed, we can go, okay, I don't want to go above 100. That's not like, I tried recently and you basically get quality at 0.3. 4 hours. Okay, 4 hours 36. Okay, let's check what they do here? Oh yeah, let's remove the brim. I hate brim. Support. Build plate adhesion. We don't need anything here. Just skirt it. That's already like a few minutes off. No, it's not designed to be flat on the side because this thing is sticking out. This plate here is thicker than the plate of the tube. It's basically, I don't have a bigger nozzle, sorry. We could make a bigger nozzle. Okay, infill, oh yeah, infill we can do maybe 10%. There are not many, but that doesn't save a lot. Maybe even 100%, so 4 hours 28. We could, I have a nozzle, wait a second. We can drill out a nozzle and then change the nozzle, but I never did this on a printer. And then we have to calibrate. I think if we try to change the nozzle or make a new nozzle right now, it will just add up 1 hour, and at the end we won't have a good print. It's getting cold in here. So let's stick with that. And we can maybe, so let's preview the support. Okay, the support, okay, this support here is terrible. So this whole plate, I'm not sure. I'm not sure about this whole plate here. The infill is okay. This is already very sketchy. It's only 2 walls thick, but it's basically designed like that. Okay, we can take off here this part because we don't need like, I will optimize the model now. Let me do that so we can skim off a little bit of print time there. Okay, so let's do a cube. Oops. Ah. Let me show you. Oops. Let me show you. Oops. Okay. I will basically cut a slot in here because we only need to hold the balls inside of this part here, but it doesn't need to be like closed or anything. So we can basically remove like a whole section like this. This is the top of the print. I think we can maybe even more. Yeah, let's do 30. Okay, let's cut it out. Bam. Oh no, that might not. It's a little bit much. No, 30 is too much. Okay, let's do 25. 25 looks okay. Okay, let's hide that. let's export that. Save. Reload and reslice and three hours, so 4 hours. Oh, it's 1 o'clock in the night when we are done with that. Shoot. I have no clue how to optimize it any further. Maybe make this plate smaller here. Okay, let me check that, because we could possibly make this smaller. Let me hide everything. Where is it? Oh, this here. The mounting holes are only like, we can do it like within. We need only 27. This is what we need. And this is should be somewhat centered there. Where is this second cylinder that we cut out? This one here is oops, was 32. Yeah. Let me show that again. So this cylinder is 40 millimeters across. And we have 35 for this thing. 35. So this thing is way too long still. This is maximum what we need to mount it. Okay. I think we are good now. This will never work. This is the first thing that breaks off. Make the plate 45 degrees. Yes, we can do this. This is a good thing. We can do this. We can even move that up, because the mounting holes are like, this is, the bevel is terrible now. I can't remove it. That's one thing that is not that great about. I think we can remove all supports now. We don't need any supports right now anymore. So, oops. I would even go as far as say, oops, move that even further because deselect first. Okay. Come on. Okay. Okay. Let's leave it like that. We could even move that down a little bit, like that. I don't know if this... Oh, no, that could be even slower because then we have like this overlap. Okay. Let's save it. And now we don't need any support whatsoever. Maybe even... what is this thing now? Okay, this thing here. We can modify that as well, since this looks a little bit chunky. Oops. Okay. Okay. This is what we print now. Okay, Cura reload, and then support. No support whatsoever. Ooh. 2 hours and 32 minutes. That sounds great. Do you think this will stick? Or should we add just or do like a super shallow support only? Generate support and then like 80 degrees or what? Like that. Oh no. It's a little bit longer, 85. Or 80 and then not everywhere, only touching build plate. That's a compromise. Yeah. 70. How about that? Still the same? What? It doesn't generate anything. We show that. Yeah, it does a little support here. That's cool. Okay, dudes, let's print it. Shall we? No more wasting time. 2.5 hours. File saved. I need to change the filament. I don't think I have enough filament. Or I print it right now and then It has like filament detection, so I will have to switch later. It looks so fragile. It will be fragile. We can add like a layer of hot glue on the outside later. Oh, wagon loads. Where are you living? It looks fragile. It has only like two walls of, it's like a, well, I hope that works. That will be like, if it doesn't, no print cam. Oh, I don't have one, sorry. I could move the printer in here, but then we will have like constant noise. Okay, I pulled out the SD cards too quickly, I think. Or I need to restart, eject, okay. Let me check that, not that the card is broken and then I... Okay. You know the best tool to add adhesion to your build plate? Steel brush. Okay. Why steel brush? Because often, yes, scratch the surface and make a better stick area. It sticks like really, if your print doesn't stick to your surface, use a steel brush. Just try it. It doesn't need to look pretty, it does need to stick. That's the only feature of blue tape is that it has like this rough surface. Okay, we can use the second printer, since I have two printers, to the Prusa. Yeah, I don't have fancy features like a magnetic build plate. So we only did one part, but there is something missing. Okay, we need to attach you even see it. We need to attach a small servo on here, so we need a part to design a part to do this. Split the design. Yeah, Aaron, we need this the printer to do like, do not tell Prusa. Why? Yeah, I should do another, but I hate doing reviews. I don't like it. Like very we're having a 360 turret as well. So yeah, that's the lower part. We need to print that. We need to finish this because we need the loading action to this servo needs to be mounted to the back, or we glue it. Hot glue. Okay. We hot glue it. Okay. Okay. This is done. Okay, this part is done. Now we need the turret. Okay. How do we do it? We have some ball bearings here. G-string printer. Okay, ball bearings. I think we can make it based on that. Chat telling about drilling sauce and hot glue for ages. Lazy Susan. What is the Lazy Susan? Yeah, Lazy Susan. Yeah. Something like that. But let me check if I have like a small wooden plate where we can mount everything. Ah! Okay, this will be our base plate, I think, and then okay, we can do one part with woodworking and the other part the turret part. How do we do it? No, it's easier. I think it's easier to print it, really, with the second printer. Oh yeah, oh, I need to check the print. You're right. Oh. A few minutes lost. Okay, let me switch the camera now. Let me switch the camera. Okay, so I have to start all over again. The filament broke right before the, I think during the retraction or something, right before the feeder, and it wasn't detected or anything, and it didn't print anything, so I have to restart because the first layer is really important. Okay, so I bought these things. These are really cool. We can use that to move the fail print, fail mic. Oh, why is it so cold in here? Where's my jacket? Okay. Okay. Yeah, the feeder is skipping steps because give me a few seconds. Layer is done in okay. This will be fine. The print will be fine. Okay, everything is all right. Now, what do we want to do? Okay, I need a mock-up or something for that one. Let me switch that off again. Rank 2 on the importance list. Chat should spam fail TTS so much. No mic. Can you? Oh, you can't hear me? Where's the fail button? The TTS. Yeah, people, it's your fault. You didn't vote the right things. It's not my fault. I would do TTS today, but we have to do this launcher. Yeah, I'm like two rooms across, so probably that's why it didn't work. Yeah. Okay, I will stop talking when I'm over there. You voted for MIDI flute. I have everything here. I can show you. Just as a teaser. Just as a teaser. So you vote right next time. And balloons. Like, these are like proper thick balloons. I think I will use them as lung. Use like, fill them up. And then some kind of vent or something. Manual nerve gun. You didn't vote? Oh yeah. It's all your fault. Yeah, we need to like fix the old broken things. Okay, this was another project. So the flute is going on the list for sure every time until we build it. Let me check the print. Print looks shitty already, but whatever. Okay, so here we go. I need the caliper. And some action here. So we need another cube here because we need to start the print of the other part as well quite soon before we do the code. It's your fault again, Dave. People will hate me that I use Blender again. Okay, so let's... Oh, we don't have much room in here. There needs to go a bevel. Like that. This will be print flat. Oh, we need some layers to it, some layer adhesion here. Where is my origin? This looks terrible. Wait, what? Oh. Oops. Huh? Oh. Yeah, this is it. Now we have the motor over here, which is spinning at crazy speeds, so this needs to be higher. Oops. Ah! So the motor will be spinning. Show me the motor. We need this clearance. So this is the mount. This is already looking quite thin. Hammer for soldering. Okay. Oops. Modifier. Mirror. Hä? Is this one? Yeah, no, we need Y. Okay. Something like that. What's the thickness of this thing? Okay. 2 millimeters, is this enough? I don't think so. I would say 5 millimeters at least. 5 millimeters and leave like a little space here. Maybe 4. I don't know how long my bolts are that I got. And we have 1 millimeter in between, that's okay. Okay, great. I think a cut would work faster. What are you talking about? This is like super fast. Okay, so we have this mount here. It doesn't look very solid though. Yeah, I'm not a perfect example for great modeling skills, even in Blender. Oops. Wrong. Okay, it's jetzt. Now another cylinder. And this one will be how many? 5 millimeters max. And this will be like 60 and 60. Wrong. This will not work. This will not work. This is already so heavy. This will be like super back heavy here. This will never work. This will never work. We need some space back here also. I have no clue how to do this. Okay, let's do it like, what is the ball bearing size here? Okay, we don't need to like submerge it completely, but we need 5 millimeters for the ball bearing, so let's make it 7 millimeters. 7 millimeters, and now oops, no, 60. Then we need a radius of 10 centimeters. This will print forever. This will print forever because we need the one servo to be mounted here, the one that tilts. Screw the, oh wait, we don't need like a, it doesn't need to be like round. I just remove it. I do a square base there. Oh, you mean like, no, I do it like that. Sorry, not sorry, but I will do it like that. This will be, no, this is the right 7 millimeters, like that. $31? Really? Okay. I need something to glue on the thick servo. The thick servo goes there. Even further, like that. There goes the thick servo. This will be terrible. Okay. We can hide this one here. Okay, I see like we need to put a ball bearing somewhere here. So I rather need to extend this a little bit. Show me the motor. Motor still clear, okay. Then we need to take this thing, move it like that, maybe motor clear, okay. what? Like that. This needs to go like there. How many centimeters do we need to mount this? We just glue it in place or something. I would say like 3 centimeters. Yeah, let's do it like that. And now we need this bearing down there. So we need another cylinder. The size 22. So we make it what? Oh. Oh no. What did I do? Okay. I was still editing this while adding the cylinder. Okay, now we're talking. Okay. So 22 millimeters diameter. So we need like 22.4 at least. 4. Wrong. 90. The height will be 4 millimeters. We have 5 millimeters. Okay, so this is the ball bearing. Oh, wrong. Okay. Oh no, we need 6 millimeters here, 6. And basically let it stick out a little bit. 2 millimeters, that's fine. This is not balanced at all. This will be like a huge failure. Okay. Let's add parts and print it. Okay. This is basically our base. You need gyro stabilizers. We have a gyro stabilizer. This thing will be a gyro destabilizer, probably. I eat my head if this thing will work. It's like not balanced at all. I think we will like glue maybe something to here, but This will never work. This is crazy. Okay, I need some... Shall we make it a little bit wider and... Oh no, this is rotating. We need something on the bottom that's not rotating. We basically screw in the ball bearing to the plate, and that's all. Okay, I need to come up with something there. Use a Spax. Okay, let's print this thing. But I need to add okay, store this and XDS selection, and this is the base. This is like, this will be not working at all. I think this motor is too heavy. It's like very, this is the heaviest part on this thing. Maybe we will just pick another motor and modify it a little bit so we can use it. Do I? Oh, wait. How about basic DC motor like that? Oh, oh, that's a good idea. Look at this. I found this. This is like a vibration motor from a controller. And basically, we could use something like there's like this foamy, rubbery foam around it. We could use rubbery foam on our launcher. Okay, we will come up with something. We will come up with stuff. I need to add another printer, and that's the, yeah, P as Prusa. Prusa MK2. Okay. Basically the same features. 2 hours. What? 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 Why? Oh, print speed. Oh, that's completely new features. Oh, layer. Oh, yeah. Let's do layer. Okay. That's more about it. And we don't even need like super speed. This will be a quality part. Or do we do like faster, like 70? Yeah, that's doing nothing for us. Let's keep it 60, okay? Okay, I will grab an SD card. Do I have a SD card here? Some SD card that's recognized by the printer. Here, this one, probably. I didn't use the Prusa for ages. I hate it. The print plate is always warping, so probably it won't stick to the build plate. Oh. Oh, this SD card isn't working. This SD card is broken. I will just throw it away, I think. Oh yeah, okay. There is an Android on this SD card. What do we have here? Yeah, whatever. This is good. Buy a Prusa, I hate it. That's a good spot. Prusa didn't sponsor me anything. I bought this printer myself. So I can complain how much I like. And it's an old one. Okay, this one is loud, but I can actually bring it over here so we can print it in here. Oh, it's dusty. Oh, I didn't treat it well. I need to clean it up a little bit. Let me move show the camera. I will let it run on the carpet. The camera. So, and then we, wow, I need, there's no lighting at all. And this stream is sponsored by Prusa 3D. I don't want to put it on a table because it will resonate and it will be really loud if I do. I need some, let me turn that on. This thing, how do I turn it on again? Here. Since I got the other one sponsored, I'm using the other one because it has a few features more that I like. But I kept this Prusa just for the direct drive. So whenever I want flex filament, preheat heat PLA. There is some remains of paper glue that I put on. Maybe I put it on this plate here, just for the time being, so we don't burn anything. What is this? I checked on the other print, it looks like really paper thin. Okay, let's check how we can load a filament here. This is like, what is this gunk? It's like really old. Oh, this one is broken off even. Oh no, I pressed reset. Oh, it almost looks like something dripped on that. Okay, it's poor printer. Preheat, and we also want to load filament. Somehow this old gunk solidified. Yes, okay. Now let's perform our print adhesion, build plate adhesion action here. I think this is fine. Print from SD card. Okay. Oh no. Oh no, I showed my ass. Oh no. Okay, now I need to adjust, probably adjust the height. So tune. No. Where is it? It's calibrating still, okay? Oh, the Z looks good. Okay, I think we are fine here. Yeah, this will work. Okay, and the other one, yeah, I don't have wireless transfer, but I will just check it. I I think I think 2 layers only for the other print. It's so thin. It's like it's thinner than this here. I think we might put a paper roll around it. I think this will fit just on top of it, just to make it sturdy. Okay, now we need to do the electronics, don't we? Oh, Prusa is printing well. Okay, let's check what we got here. So we need like one of these here, Servo controller. We need an ESP32. Let me grab that. Oh, we could use an ESP8266 for that. Wouldn't that be sufficient? Oh no, Brian's library only works with once Prusa snob, always Prusa snob. Yeah, 60 channel servo controller. 16, I mean. Okay, wait a second. For Brian's library, we need ESP32, but we got plenty. We got plenty of ESPs here. I might even like use a dev board, or do I? No. Does anyone know if Brian's library also working with ESP8266? If so, it will be easier for me. So I don't have to solder anything, because otherwise I think I might need to solder some pins on. Where's my box with all the microcontrollers? I had it here. Here is one. There is a tiny Pico. Okay, I will solder on the pin headers. Oh, I have more lights here. Give me a second so I can give you a view. Just need to set up everything. This will be definitively a thing that I won't do a video on, so because it will be so jonky. That's a mixed word of honky and janky. Okay, power supply. Oh, can I show something off? Since I'm cleaning my lab right now, as you can see, it's a little bit more tidy, except for this corner over there. I printed recently these holders from Thingiverse. So I have my probes, my USB cables, my power supply cables. Everything is now nice and tidy over there. Cool, isn't it? So don't have to like look for the parts all the time. I'm still not finished. There's a lot of work to do. So I need a thick cable here, a flexi friend cable. This is like a silicone tube, silicone cable for the power supply. And I need to plug this in. Okay. Oh, I think I changed the tip. Yeah, I'm almost done. I hope you are enjoying yourselves in the chat. I will check on the other prints soon. Sometimes the pin headers are really like cheap or something. The solder won't stick at all. Like it's dirty or something, I don't know. Need more heat. Okay. I think this is okay. Now, Q-tip. Okay. The print again. Still going. Oh, wow. Okay. I have a slight problem with the other print. I can show it. Another 16-hour marathon. No, I will. Oops. Okay, so this part, this opening here, while printing, it somehow moves together. So we have like an oval here. The ping pongs might stuck there. Just loading, just loading. I think it will be it will be okay. So this might be like a little bit oval. And it's like paper thin. It's like really paper thin. Oh, here is even something missing. I told you so. You told me? I didn't read. Okay, never mind. Are you winning? Yes, Brian, I am. I was asking if your library, if your chat library is also working with ESP8266. So is it? Is my question. My question is if it's working with. Let me grab proper USB cables since I have like good assortment of USB cables now over here. In theory, what does it mean? Okay, I will do it with an ESP32. And what do we need to do for that to work? Fail. Hair dryer. Yeah, I could do that. Read the instructions. Never. I never read instructions. Accident logger. No, what's the name of our project? I'm looking for the project now. Chat notifier. Yeah, that's the one. No, that's not the one. Here it is. Okay, so this is our live streaming. I will just save it as a different sketch. Oh wow, that's like too much too much code, too much text. Okay, so that's an ESP8266. Okay, so we could have used it. Okay, thermal printer is. We don't need thermal printer here. This is that we streams Arduino JSON. Yeah, that text. Oh, I'm still waiting on the PR to make it simpler. Yeah, do it like in a library that I can get from the library manager. I don't want to like every time someone fixes a bug, I don't want to like launch Git and try to pull something and update my code and whatever. Okay, number of trash. Oh yeah, we had a video ID. I think we had this hack in here. This is still a hack from last time, isn't it? So it's so much code. Video ID. Yes, I am. I'm just I'm just giving you the worst user experience, the worst experience regarding how a user would perceive it, that is really lazy. So let's get this video ID. This is the video ID. Yeah, let's just upload it and see what happens. And then we need to add like the other stuff. Yeah, that sucks with manual libraries. Such a diva. Okay, while Arduino is compiling, I go and check the other one. You watch this print while I'm gone. Oh, shoot. Yeah, whatever. Okay. So we might have a slight problem with the loading tube, but other than that, okay, we have a serial monitor. Did anyone try fail? Oh yeah, it did something. Ah, yeah, okay. So, this is working. Overloading tube, yeah. Okay, so this is not a fail. Fail. Let's do it ping. Because it's a ping pong ball. Oh, we didn't check off any boxes. Oh, and this is like UDP. Oh yeah, that's like the lamp notifier. We don't need that anymore. And it was the thermal printer. We don't need that. That was the beep. We don't need the beep. Okay, we can leave the beep. Fail, no checkboxes. Oh, we really didn't check anything off. CAD models. We are done with CAD models already. Let's. That was the worst. Print X and print Y. Oh, tube. Chat control. We are working on the chat control. Okay. Don V1, yeah. No, I don't want to stream like for ages today. Oh, I think this one is getting already like the covering thing. Okay, how do we parse? How do we parse? Do we need a tokenizer? Okay, so what's is it? Okay, let's do Pong, not ping. Let's do Pong. Pong, okay? Pong, and then we do like an angle, okay? So, okay, let's keep it like that. And that's right. Chat message. Okay, let's upload it. Selected the wrong project. It will be fine. I get it off my table. But please, next time, let's do a proper text-to-speech and stuff, and don't vote for like a remote-controlled table vacuum. Wait, the lower bracket is there to set an angle? Yeah, we will see. I have like this MG996R. It will be okay. We can make it work. Overboard. Here's a small spider that's like knitting a spider web across my room. This spider is like 1 millimeter across, and it's doing like a climb of 1.5 meters. Put weight on the other side. We will have enough weight, I think. Okay, so we had this servo shield. We need to connect the servo shield now. How did we do this in the other project? Oh dear, this is like... I already forgot how cumbersome it is. Oh yeah, Pong. Yeah, it did something. Pong 180 20. This will be the syntax. Something like that. X and Y. Like pitch and roll. No. Yaw and... What is it? Okay, dudes, now we need to parse it. How do we parse it? scanf s. Oh, shoot, I don't know. No. Dave Taco is the best. How does scanf work again? Like that, isn't it? I'm the software engineer, yeah. Format. Token string. Yeah, that's the one. Don't you just hate when uploading code the wrong ESP over OTA? Yeah, I must admit, I never used OTA. Maybe once, and it happened immediately, but I will need to use it in future. Oh, wait. Here's something missing. I'll be back in a minute. Hast du so Pins? Ich brauche Pins. So Stecker, so zum Stecken in der Kork-Pinwand.
Da in meinem Schreibtisch.
Ja.
Da ist doch dieses Glas.
Ja.
Da sind die Pins drin, die ich immer nehme.
Okay, I'm back. And we need the right background here. Which one do I use? The design tips 3D for printing, or oh yeah, we need this here. This is the printing station. Oh no, I need more. I need more. I'll be right back. Okay, here we go. So how do you like this background now? Oh. So it's it's a poster, Billy Rubin's poster for bed leveling, and I thought whenever I'm done with this corner here, cleaning up, this will be maybe my 3D printing corner, even if not in this room, and this will be perfect. Like this poster will be perfect to have just behind the printer. It's like really cool. A little bit more personality here. I forgot to disable the microphone. Toilet go. Yeah, the spool holder is 3D printed. Yeah, waifu knows where the stuff is. I just took her pins for doing that. It's just a temporary solution here. Oh, this is pretty. Oh, this is so cool. The other print will break in like 5 seconds. I see it coming. AKA stays forever like this. It might. Okay. So the other print is actually still working, so kudos to ANET ET4. Nice living room. Yeah, that's in the basement. That's one reason why I got rented this house, is because of the huge basement where I can live. Living room. Okay, now I got the joke. Okay, let's get back to this servo thingy. So what did we use last time? Oh, PWM servo driver. Okay. Is this the one? PCA, I must check. I can't see. My eyes are getting worse. I get this impression. Where's my... here. Oh, there are other things that I also printed recently. Also from Thingiverse, here. That's like an SD card, USB stick. It has like slots where big SD cards and small SD cards fit, and USB at once. So this is nice. And I also got, oh, here, this is the bigger version that I didn't use yet. Nice thing. And another thing that I printed from, look at this, a super simple one, just a battery tray, because they are always rolling around. This one, I think I might need to reprint it in like 2% bigger because they stuck a little bit. It's getting older. Welcome to the club. Yeah, unfortunately. So let me check if this is the PCA. Yes, it's the PCA. Is it the 8.5? Yes. Yeah. Okay, so this is the servo. So we need wire. Client secure UDP. We don't need UDP anymore. Oh no, we can leave it there. We can leave it there. Maybe we need it later. Oops. Yeah. Oh, we did a scanf. I didn't change anything there yet. So D and D. And what was the yaw on what was the pitch? Pitch and yaw. Yaw is the rotation. Ah, yaw. Yeah, that's the yaw. Yaw and pitch. So we get yaw and pitch. So this will be yaw and this will be pitch. I saw that. And yeah, I don't mind. I don't mind to admit that I don't know everything. Yaw and pitch. Maybe let's do it like that. If there is an error. Oh, what does scanf? What's the return value? Is it? What? Okay, we just need to scan two fields. So if maybe we should add like a message on top, like S. So but how does it delimit this? Okay, whatever, no message. Let's keep it simple for now. So, and now we need scan for 2. Yaw and pitch. No. Where is it? No. Huh? Servo, there it is. Okay. It's looking for that servo driver. Okay, let's keep that stuff. And let's make it like you should do it. Because I hate unnecessary predefinitions. The compiler has to decide when it's optimal to substitute anything. PWM begin. Oops, no! I need to refresh my token now. Ah. Where are my tokens? Yeah, basically I just doxed my auth token. Okay. Here. I can't dox it anymore. It's in a different file. I mean, okay, I should rename the file so it's not shown. I used like by accident control and whatever. So that's why I doxed it. But now I can't dox it anymore because it's off screen. Again, I did it again. Okay, begin. What is that? Okay. Okay, set up. No calculation whatsoever. Okay, we need to calculate it. Okay. Servo 0, this is your and this is basically between 0 and 100. Oh, first one is printed. No. Oh. This one. It's sturdy. I need the cutter. The other one is also, even if it would fail, we would have something to work with. Okay, nice. Whoop. Okay. Does it fit? Of course it doesn't, because it's like, the first layer is always a little bit. Okay, cool. Oh, I can't get it out anymore. Oh no. Let me get it out. How? Where is the rod? I need a rod. Something. Okay. Now we only need to find the right thing to mount it. This looks great, but okay, let me get a piece of wood, because yeah, it will be like that, and we need like a little more indentation in here. I will basically drill it out. Still too long. Ah, I need a thicker one. Okay, this one will work. Great. Okay, we need this here. Oh, the image is blown out here. Here we go. Oh wait, this is like a 6mm that I got here. Let's take 6 then. 6.5. 6. Whoops. Oh. Need more. Oh, that's too deep. Oh well, let's keep it. This is terrible anyway, so that's already rotating. Okay, I'm just stuck in a flathead here, so the nut will stop rotating. On the other side, I have just a lock nut. I'm not sure. I drilled a little bit too deep. This holds. Now we do a slight modification on the 3D print side here. That will be V2. I think I'm a little bit off center. Shoot. Okay, let me use another drill. We just need to accommodate the head here. I think this is okay. Looks like it was printed in the first place. Just like that. I don't own a deburring tool. I forget always to order one or get one in a hardware store. Okay, so here we go. It looks like it was printed like that already. So this is version 0. Let me clean this a little bit. Ah! Okay. This is rotating quite well already. Okay, so this cannon will be like here. This will be one servo. Like here. Or I will mount it like that. I think we can almost mount it like that on this wood piece here. It's slightly too low, low here, but as long it's just hold in place, it's all right. So we need to hold it in place. We need a servo arm. The problem is with these servo arms that I own, that they are crappy. They don't hold. They don't fit well. But it's nothing that we can fix with hot glue. So look at this. Oh, this one even fits. Okay, cool. So we will be just using something like that here. Just a basic here, attach it like that, and basically we can just stuck it in here. That will rotate plenty. Okay, now we need the second part, and we need to program it. Okay, I will read the chat. What do you think? What do you people think about this? The story of printing PLA is just to drill it away. Also at the Makita drill, that the auto chuck went in it after a couple. Makita. Canon is a launch. Yeah, I mean, I don't like oppose confetti cannons, so so glitter cannon. Except in my lab. Launch a ping pong ball. Oh. So did you buy it from Makita or did you buy it from somewhere else? I got my off, I think it's like a German online shop. Yeah, but guns, I don't want to use the word gun. Maybe Canon, I should avoid Canon as well. Amazon, okay, too lazy to look for. I think, what was the shop name that I used? Something with P. I just always look up stuff like that on guide sites and then pick the cheap one. And it's quite often not Amazon. I don't want to support Amazon if not necessary. Just passing by. Ping pong launcher. Canon, Nikon. I must admit that Pauline. Yeah. The other print should be finished quite soon. We should continue with the software so we will be able to use it here. Okay, so can you cut out a channel under the wood for the servo so you can direct drive the turret? Yeah, cut out. I don't have like any tool that would do that. How do I? Okay, I can chisel out something. Oh, you mean underneath? Okay, we could do this. But first of all, I would need to cut this. Yeah, we can try to do this. Yeah, chisel it out and mount it there. Okay, let me just cut this part here. I mean, here you didn't see it. I will just cut it shorter. Oh, that will be a mess. You know what? Let's say I want it here. I will just spux it and then we are talking. A little bit too short, so I need 35. Is this the right size? No! The only problem with Torx screws are that you never pick the right bit. And you need exactly the right one. Here is it. I'm not doing a pre-drill here in the hopes that the wood doesn't break, but okay. Ah, it broke. Shoot. Ah! Ah! Let me do a hack. Here we go. Oh no! It's like right there in the corner. Oh, you wouldn't be able to see anything here. Oh no. Okay, let's cut it now, the remaining wood. I messed it up already. I should have pre-dried it. It was a terrible idea. Okay. Okay, launcher is still rotating here. Ah. Now we need like to put something below. I need a second piece like that, so we can inset the servo there. Okay, good enough. I think it isn't the right height, but it can be at a pitch. And this will be good enough. So how do we do this? I just need the tools. Okay. Please, kids, don't do woodworking in your electronics shop. Okay. Wait. I don't need this part anymore. Ah! I don't need that part anymore because I'm using this one here underneath, like that. And then I can basically screw it in without... okay. It's a more tidy solution, I accept. But how do I get it out there? Let me disassemble that. What happened 4 hours ago? What? Norway? In Norway? Norway is like dream country to live, isn't it? I always thought that Norway is like the best example of countries that are quite livable. And I think it still is. Just put it there. Just put it here. Okay. Oh no, I just lost my washer in the trash. There's my washer. Okay, I found it. Oh, now it's really flush. Okay. Okay, tool still working. Now we need something to Servo needs to go like here. whichever direction we want. Okay, this is the maximum. Okay, we should keep it like that. Oh wait, there will be like another servo like that, which is basically glued on here. So this is the radius, and now we basically oh, there goes a hole in my table. I should put something below that, like this slat. Ah! Seconds since accident 0. Look at that. Thankfully that wasn't my table. I saw it, at least I saw it coming. This table is really stuffed right now. Okay, so let's do some basic woodworking. Okay, maybe I should use the slat again. Where's the hammer? A proper hammer here. Not that one. Uh-oh. Small hole on the top, big hole on the bottom because it's plywood. Okay, whatever. Let me put that thing directly on the wood here, so I don't have a springy action here. Way better. That thing came off. Okay, let's see. Oh. If it fits, I sits. It's a little bit too narrow, but we have something for this. Oh. Okay. How about this? I get a vacuum. You people wanted that I do some woodworking. I did it. Now we can move on. But I need some vacuum and remove my tools. Oh, the print finished. What a joy, the print finished. Okay. This is like a temporary thing. I don't know if this will hold up. Okay, let me get the other print. Or should I read first? I read the chat first. Yeah. I didn't think about this in the first place. So let me grab the other print without breaking it. I hope it works. Ladies and gentlemen, this is the Blaster Master. Look at this. It's like paper thin. Okay, this part somehow, it's a little bit on the narrow side, but this tube is awesome. Okay, so let's mount it. I need some long 3mm screws here, and we need like the outrunner there. Okay, so the idea is I use these screws here. I remove this plate, and the outrunner goes directly in here. Or I could even leave the plate there. No, then I don't have anything to attach it. Yeah, okay. Let's see if that works. Now let's check with the ping pong ball. Oh, retention loading. Oh, this is tight. This is like really tight. Oh no. Oh no. What did I do? Okay, this will. There is no way. Okay. Here, this part is narrow. I need to like remove there something. Here we get like I need to, how do I do this even? Maybe I just cut it here and use this paper thingy. Okay, let's leave it like that, but why doesn't it somehow get stuck there? Oh yeah, there's like a knob. Oh yeah, that broke. There's like here small 3D printing residue that prevents the ball from falling in. Let me get the smaller knife here. Shit. Oh no. It's a little bit narrow. Oh, this is like, this will never go through. How do I, this is like, this would work with the CO2. Or I need to shrink shrink the ping pong ball. Let me load it. Okay. Okay, that print might... but it's like really close. We are really close. It's like less than maybe tenth of a millimeter. I could probably send this. Let me try to send off a little bit excess there. This one got stuck. Okay. Where are my cable ties? Let me get a cable tie. Oh, rubber bands are also nice. Let's make a tool. Okay. Okay, until this artifact here, it basically rolls. Okay, this one is fixed. Now I need to get rid of basically use my tool there as well. Can I do this? Now it gets, oh, wait a second, this is a different ping pong ball. Okay, I might need a little bit more tolerance there. But this one works. Okay, we got one working here. Okay, this is our showcase tool. Now we need a wheel. you just use a few rubber bands like that. Maybe, I hope they don't fall inside or anything. Okay, this is so tight, we don't need like this extra. Okay, okay. Now I need a screwdriver. X-rated, yeah. So where's Dave Darko when we need an animated GIF? That tool is like really perverted. A wooden wheel. Okay, first action is, can we mount this so it will launch anything here without it destroying itself? Like, oh wow, oh no, we need to drill a hole there as well, because there is still the axle here. Okay. How deep do we want to do this here? Will it launch like that? Okay, we can use fewer rubber bands, I guess. Oh, come on. Okay. No. Needs to be a bigger hole. Okay. Now we need to find the positions where to screw it in. Oh, this is way too deep. Uh-oh. I will let you participate better in our endeavors here. This is where it goes, like that, and that's way too deep. I think it must be like here, more like up there. Okay. Quite some burrs. But on the other hand, the burrs are the only part that's holding up here. The burrs have the best layer adhesion here. Something like that, I think. Yeah, I will use my soldering iron to punch a small hole there. There's no way we can drill that, even though it's not very cool to do that, but okay, I have one hole here for a screw. Oh, where are these small bolts? Here. Still tight. Okay, now we can. Oh, this is way too close there. I think I need to remove a few. Where's the next screw going? I think I will place it there. Something like that. Yeah. Maybe I drill that one. Okay. Okay. Let's see what happens. Where is the ball? One ball, our presentational, like the good small one, fell off. Where is it? Here? Is it the one? Oh yeah. Oh no, it's way too tight. Oh. It gets crushed there. Okay. Let's see what happens on camera. But let's vacuum everything off here. Maybe I would need fewer rubber bands. Let's start just with one rubber band then. Okay, we have one rubber band. Rubber band. And I don't know if I can like CA glue it somehow to the outer. It's still in the center. Okay. So let's people, are you ready to experience this piece? Ready? Which direction is it? This is the wrong direction. Okay. Okay. So let me swap just two of the two wires need to be swapped for it to rotate in the other direction. Come on. Who puts so much tape on that? Okay, let's try again. Whoa! Oh shoot! That totally works! Oh shoot! Did you even see that? Whoa! Whoa! Okay. So you can see that. because the frame this is crazy already. I just put something there, like this wooden block. Okay, this wooden block will not fall over. Probably not. Let me put something there. Oh yeah, here. So we might be too close to our section. Yeah, might be too close there. Okay, I will just put in 2 of those and see if we can shoot it. Whoa! That was the first one. Okay, the second one gets stuck. Okay, the second one is too big. It gets stuck there. I don't want even put my fingers in there while the battery is still on. Okay, the second ball got really. Oh, the rubber band is broken. Okay, the rubber band is already like. Let me just disconnect it from the battery. Otherwise, I get like destroyed over here. This is crazy thing. Okay, unfortunately, it's a little bit, yeah. It was like indented, and basically the rubber band is molten. There's like the remains of the rubber bands. I'm asking myself, is it inside though? Looks like it got like, oh yeah, it's pulled inside. The remains of the rubber band are pulled inside. Let me just get it out with tweezers. Oh, this is even better. Oh, and this screw even undid itself here. Okay. How do I get it out? I think it will basically melt at some point and be good. I don't want to. Okay, I got it out. Okay, let me try again with the other ball that doesn't get stuck. Where is it? I can find it. It turned out to be a cannon. Oh, it's on the table. Okay. Let me check out if we even need this rubber band. Yeah, we need it. Okay, no rubber band, no action. Okay, let's use something else. Either a balloon, it's also rubber, or I get a thicker rubber band. Give me a minute. Hello. Okay, I found this one which perfectly fits. Oh, look at this. It's a thick one. That should fit. Oh, it might, due to the acceleration, it might expand so much that it will basically, yeah, fall off. Let's try again. We need the obstacle here. Oh, just what I said. It just took off. The rubber band just took off. Okay. Okay, that will not work like that. It must be even smaller. Or I need to put it on like really tight, like twice. But this is like, oh. Ah. 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 Okay. Okay, we have now a thick rubber band. Okay. Okay, we need to and stuck. Okay. We need like really speed. Okay, this is the direction. Oh, I see what happens. It rubs at this corner here. I think I need to take a little bit off here because it rubs at this corner. It's too thick there. Where's my knife? Oh. Shoot. That wasn't good. It's basically falling apart there. Okay. Okay. Where's the ball? Okay, that can work. That we can work with that. We can work with that. That was like the perfect showcase. I needed to push the ball a little bit. Flump. Okay, I love it already. Okay. I love it because of the educational part of it, not because it's shoot out balls like really fast. That's not what I love about it. Okay, let's mount it and finish that thing, shall we? Oh, what does my battery say? Okay, the battery of this transmitter might be dead soon, but I will switch. Okay, I hope that my got some ammunition. I mean, hope that this is no 40 millimeters. Oh, and it's also, oh no, yeah, we might want to drill that out because, oh wait, if that just screws in, we don't need like a nut there. Okay, so let's. Oh, I need washers. Ah, whatever. Okay, that will hold. Oh man. What the? Okay, the motor. Okay, we need something like that here. Let me get the hot glue. Ouch. Hot glue is actually hot today. Ah! Okay. Oh, that's not good. Okay, we need another hole. Okay. I abandoned you all. Hot glue. Yeah, hot glue gun. But first we need to do like the yaw. Which is basically this. This is the yaw now. Let's see if, oh, this is like, oh. I hope that angle, oh no. Yeah, let's see. Let's see if that works. Okay, this one should be here. This is how we mount it. We could use like cable ties here as well. It doesn't really need to be hot glue. Okay, we will hot glue this now. Okay, let me test if we can. Oh yeah, we should mount it first before something breaks here. My servo horns. Come on, I had the thick ones somewhere. I have like 80 servos here, and I tested each of them yesterday. And I just realized that even if they appear broken, if you just hit them a few times, like smack them on the table, they will recover. I can find the servo horns. What? What would I use butter for? Should be another bag with the thick servo horns. Uh-oh. Okay, I need to check if there is like, oh, there must be somewhere another bag with horns. Ah, here they are. I should also screw this to the wood plate. Otherwise it will move around. Okay, this is mounted. Now we need the second one here. And this doesn't like very loose. I will I will basically use a drop of hot glue there to make it like sit on tightly. Yeah. Okay. This is the spot that we specifically made for this. Maybe I should, yeah. No, this is like, okay. Do I have the power bank? Oh, my back hurts. Okay. Before I try again with the big battery, I will just use the servo tester to set up the range. Okay. Okay. So this will be like, okay, this must be here, I would say. And it will be like this. Okay. No, if it should be like parallel. That's the best. Otherwise, it's not linear for you rotate it. So it should be rather like this. And then like this. Okay. I don't know if that works, but let's check it. Ouch. Okay, let's attach it. Yeah, this will detach. Okay. And the other one. Okay, this is a little bit hefty. Okay, that should do for now. I think the attachment point that's further out should be better for that one. Let's remove that one here and okay, one servo is missing. Small one. Should be something like that. Give me a horn. So who said bitluni isn't capable of doing a project in one night? Who said that? Uh-oh, I might have used the wrong screw here. Okay, let me test that. Uh-oh. Uh-oh, I locked it up. Yeah, that was the wrong screw, I think. Yeah. Ah. No. Now it's repaired again. Okay. Okay, we will glue it like that. Okay. That's it, people. Okay, let me show that from a different angle. Okay, This is the one that pushes in the ball. Then, okay, this is like, let me attach this one here. This is the tilt. Oh, this is the tilt, and the yaw is a little bit fast. So we could basically, okay, we can attach it to a different. Maybe we should do this. We will attach it to another hole here. Pick, 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 pick. Yeah. It's not optimal to do that, but I will do it right now, because otherwise and I will add some glue to this horn, because that thing is annoying. It's like cheap horn. Okay, let's take the middle here. Okay. There is one screw missing. Here. And the code, of course. Oh no. Need to clean this up, this hole. Okay. This was the hot glue from the hole. Okay, and this is basically okay. I think that's it. We have this tree. Okay, we need to aim it at my desk later, but this thing we will use to. Okay. Okay, that's a ball that's working. The most are. Okay. So we have some cool balls here. How do I get them out? Ah! Let me fix the opening up there. We'll just use this. This servo rod here, maybe that fits. Okay, whatever. I just put them in right now. I hope. Okay. I think the last one will get stuck, yeah. This is just for decoration. The last one is just for decoration. Okay. Now we need to get the servos going. A battleship. Turn it on. Dust from falling in. Yeah, it at least spreads it so the other ones don't get stuck. Let's wire up B7. You sank the battleship. Let's wire up the PWM thingy. Okay, maybe I can just take a look how I did it here on the other one. And let's try if we can do anything there. That was tough. I need a break for a second here. I told you it would work. No, it's not nitrocellulose. It's not flammable. I tested it. I even showed it somewhere. That especially these that I have here, that I linked, because I got so many comments on my videos that that's dangerous and it will burn up the house, and then I just showed that it's not. These are not flammable, or let's say not easily flammable, like combustible. Musical keyboard is lurking. There? Yeah. My MIDI keyboard. So this is V, CC and ground. Okay. Okay. I can just take a look at the other wiring that I did before. VCC ground. That's all I need. OE? Is OE? No, it's not connected. I'm checking the wiring of our cool project that we did before, the Flippy Flip. The first version was with used the PWM thingies. So I have the wiring there. Just inject alcohol into the balls if you want a fire show. Yeah. Ooh, I shorted something. Ay, 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 ay. I touched with the jumper wire, I touched a pin here or something. This is ground. Okay, this is VCC. Then we have SCL and SDA. Okay. SCL. CL and SDA, okay. I think that should be it. Let me test that with a servo. I read the chat every 5 minutes. That's not true. I just proved you wrong. So what's the problem? Only 27 viewers? Yeah, it's a long stream. I don't mind if it's only a few. Many people. Oh, I see my battery thingy. I just switch the transmitter. Okay. Okay. Can you hear me? Yes, perfect. High latency neural network. Okay, we got power on this one here. And now let me run this PWM, this servo thingy. I will just upload this on the and see what happens. Okay. Which one is it? Oh, come on. Oh. Okay, let's see. Can you upload to GitHub? What? My Discord link is link bitluni.net Discord. This is okay. Oh, did I destroy it? I think I need to restart. Oh no, look at this. I need to restart it. Upload your ESP sketch. No, I won't. There's my key, my API key. I might do at another time. 1 day challenge. What did you post there? Oh no, my ass. Oh. Oh. That's probably more like that. Okay, whatever, I need to restart it. So I close all windows there. So WebSocket client, yes, well, whatever. What is that? I always put bot ID, Canon. Oh, you know my Wi-Fi password. Uh-oh. Ah, this is terrible. I didn't save my, where's my ping pong launcher code? Ping pong launcher. Okay, I open it like that. Oh, it's 1 o'clock already. Oh no, I'm sorry. I dox every time I code. Yeah, I should use a VM. Oh. Okay. No, it's still showing. What is that? Oh yeah, I also need to close Cura. Cura connects to like every serial port. Yeah, that was Cura. I hate it. It doesn't ask me, it just does it. What? Recovery settings? Stop it, GitHub. Oh, Peter, good night. Include the logins. We are almost there, almost. It's only 6 hours now. The mechanical design is ready. Something's uploading here. Oh yeah. Okay, it recognized this. Now we need to test the PWM thingy. That won't work. Serial print. Oh. Okay, we can try this, but I will also use the PWM example because I want to see. Oh, let me change something here. Let me add one little thing. I will use this as VCC and 5 volt as supply. Oh, yeah. Oh, yeah, then now something moved. Okay, let's try the PWM servo again. Lars is testing the limits. What is the servo number? Zero. It doesn't move. It doesn't do anything. Did I connect it right? Uh-oh. Hit it, yeah. I did it. It's not stuck. It's moving, but it's not moving. At least not with the example here. It should spit out. Okay, it's. I don't know who still using that. Oh yes, okay. Servo thingy is working. Is it stuck again? No. Oh yeah, it's rotating through the servos. Okay, this thing is working. Now let's try coordinates. Let me do servo min, servo max. So Wait, what? Okay, servo max minus servo min is the range times times 100, and valid numbers are, I clamped them. Oops. Okay, let's do it between 0 and 99, even though it's terrible. But we get 2 digits there. Times yaw divided by 100. Servo min, yeah, that should be it. This is the yaw. This is the delay. Let's say we wait 200 milliseconds and then we said we fire. This will be 1, 2, servo max. $500 and servo min. Pitch. Okay, okay. Shall we try it? The servo's there. Yeah. We can fix it with hot glue anytime or tape. No need speed control. Always crank up to 11. Yeah, 11. Okay, now I need like a long USB cable. Oh no, not a long USB cable. I need a Okay, how do I do it? Do I move this complete thing? Yeah, I will move the complete thing over. Oh, this is like, can't get this one off. Okay, let's get this over here. Move this away. there will be no correlation between the numbers that you type in and the result. Okay, I set up the camera. Oh, a neutral position after every fire. Yeah, I could do that. Let me. Oh, let's update. Let's update what we did there. Okay, we printed a Y position. Oh, we didn't update anything. Launcher wheel is done. Tube is done. PWM control. Chat control needs to be, and pink LED. No pink LED so far. Okay. Let's hook it up. This thing here. Oh, wow. Okay. I'm worried that somehow we mess up in something here. Okay. This is the pitch. And I think I need some more power because USB will be glowing. Okay. Neutral position. Okay, let's do it. Oh, let's do it like this. We have the motor not on yet. What? What? Did it? Wait. I have no clue what's happening. It's not moving. Might be browned out because we use too much power there. Let me check the window. Oh yeah. Yeah, I think we have a power problem here. Okay, let me add some power. It doesn't work. We need more power. I need more power. Where is my... power connector. And I need some wires. Ah, is this the shortest wire I can find here? Whatever. Okay, whatever. We will use this one here. That's another perspective, isn't it? Okay. Yeah, we'll crimp it. Crotch cam. Sorry. I need to get over there. Let me move you a little bit. Oh wow, how do I find out which side is which? Oh no. Yeah. I need a multimeter then. It's a too thick one. I need a thinner one. Oops. So I crimped that. Now I will screw that on this receptacle. Ferrules? What is ferrules? Is this? Is these are the small tubes or what? Adernhülsen, okay. Anna, you are German? What? Ah, I need to keep track of my German viewers. Okay, I will plug it in and measure which one is which with my multimeter. Trusty. Oh, Brian is sponsored by Keysight. That's cool. So this is positive. Oops. This is negative. Okay, not sponsored. Let's try again. Okay. Okay. Okay, mates, we got some additional power here. Whoa! Not tripping over this. I wanted a flat screw. Flat. Okay. Uh-oh. This is basically dead. Let me check that. If we get... It destroyed itself already. Oh no, it should skip the old ones. Why did it do this? And we need to get like a small like twist in this. Oh God. Oh, 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 oh. Ah, only a little bit bloody. Fuck, how do I? Okay, let's try again. This bloody thing. Ah! I have no clue if that works or not. It rather worries me that this thing could destroy itself because it's somehow shorting or something. That is annoying. Or just tuck everything in place. This I don't need this here. Okay. I will basically clamp everything down. Okay, let's try Pong, whoops, Pong 0, 0. Oh, ah, that hurt. Ouch. Oh, ow. Ah. We shouldn't go back. We need to test it. Please don't pong anything yet. It will destroy it. It will destroy itself here. Okay, we don't go back. Let's go just, I will upload it. And let's try, let's find out what range we got. Did it break? It's something like, it breaks my heart. I don't think it's broken yet, but it's not far off. Oh, it will replay everything from before. We should basically unplug it until it's done with the messages. Oh yeah, there are some coordinates. Okay, got coordinates. Here we go. This is what we got so far. Okay. Please don't do. Let's try 0, 50, 50. Oh, what is this? This is the last one, 0, 0. Pong, 50, 50. Okay. Ow! Ah! It's interfering with itself. Okay, this is 50-50. Let's try out the ranges. 40-50. Okay, this is 40. Pong 30-50. This is like already limit. Okay, so let's say 35 is limit for your lower limit. 35. Okay. Let's say Pong 60-50. That's still okay. Pong 70-50. I should pay attention. Pong 80-50. Okay. Pong 90-50. Oh yeah, that's like far. Okay. But I think this is the furthest it can go. I think it's rather 85. Because the servo can, yeah. So 85. Now let's try the pitch. Pong 50-40. Is it even going that up? Pong 50-30. Pong 50-20. I think this is the okay, not higher than that. And this is already interfering. I think we need like to go only 30. I will clamp it to 30 because otherwise we can touch. I don't know if you can see it, but there's the possibility that this horn would interfere with that one. So I don't want to break it. So this is like a physical limit. Pong 50-60. I can reverse it, but let's. Okay. Pong 50-70. this is basically it. Otherwise, it will launch itself. I can try 80, but No, this is already pitched downwards, so 70 it is. And pitch equals 99 minus pitch. Okay. So you want to reverse the pitch. Okay. We should normalize it. Oh no, I don't like it. So 50, 85. Okay, so valid ranges is like, okay, the pitch, I need to reverse the 75 aiming at the crotch cam. Okay. Let me compile the sketch and then you will try to turn it on and see what happens. If we can launch anything. Okay, this already looks good. So PWM control is done. And chat control is done. So valid range for pitch is 70 to 30. Or 30 to 70. No, this is the 35 to 85. And pitch is 30 to 70. The pitch is now reversed. Okay, I will plug it in. This is the last state. Oh, that's not pitch. Oh, sorry. Pong. It's pong. Pong. So somewhere in the middle is like 60 and 50, like that. Okay. Shall we try it? Shall we turn on the madness there? What's the Try it! Try it! Whoa! Try it! Try it! Try it! Oh shit! Okay, we don't have any balls. I must put in more balls. We need more balls. I need balls in here. How do I do more balls? It's this is crazy how good we are in developing stuff. How can you buy such build such a toy in so on such short notice here? It's like crazy. Oh, let me turn it on again. Then you try. Oh! Who did this? Ah! Oh shit! Oh, what? This is dangerous! I dodged it! This is 60 frames, isn't it? So maybe it was even visible, but it's like really hot. Oh, this is cool. Let me get some balls. That's fun. Actually, we could control the speed controller. We could control it with the PWM module as well. This is cool. Okay, I will reload. It's working way better than I expected. Okay, let me turn on some music here. Let the music. Oh, by the way, I got a copyright strike on Panic demo last time. I didn't know that was like that purple motion. Okay, where's my live stream? We need some. Oh wait, we need different. We need a different music here. Let me get another music. I need. Okay. Hey, stop it. Stop it. We're not done yet. Okay, I turn it on. Ah, stop it! Who was this? The last one hit me! Oh shit! It's empty, it's empty, it's empty. Let me reload. Oh! Okay, let me reload and we do another round. Oh, sorry. Ah, where are the balls? We need a like a bigger like compartment for the balls or some kind of funnel or whatever. This is like really funny. Okay, turn it on again. And now since we are no pink LED today, sorry. Since Johnny isn't here, we won't do the pink LED anymore because it's already late. I turn only the music on and you will get the chance. Oh! Oh shit! Oh! I'm here! I'm over here! Oh, hilarious! Oh, okay. Oh, okay. And now shooting. Thank you everyone for joining. It was a blast today. I didn't expect it for it to work that well. At least it's actually aiming and oh, Johnny! Johnny? Did you have the chance to shoot me? Oh. I declare no pink LED. We will do more pink LEDs next time, okay? Next time LED project. Do you have a weak red laser? Oh! Like a laser pointer. I actually have. Oh man. We could add a laser. Oh, that's the evil one. Okay, okay, okay. I think this is the UV laser. Aaron, you're crazy. Thank you very much. That wasn't necessary, really. Okay, I need another laser. This is like UV laser. That's no good. That's no good. That's too hot. This will break things. I will get sunburn. Like, you can inscribe my skin with that one. Thank you, everyone. It was really a blast today. I didn't expect it to work that well. And I see you next Wednesday, I think. Thank you everyone for joining and and hanging in here. It is really cool. Good night. Cool, cool, cool. Bye bye.